We are live. Hi everyone, welcome back to Geeks for Geeks practice. Today in this video, we'll be discussing the Geeks for Geeks problem of the day for 16th of Feb. The name of the problem is find rectangle with corner as 1. So just consider to give me a quick +1 in the chat if my voice is clearly audible to everyone and the screen is visible so that we can start with this problem as early as possible. This was a medium level problem and I'll say that it's actually a medium problem, but it's very easy, and from this problem you will learn how to think in a brute force manner and how to optimize that brute force thinking in optimal code, like how to reduce the time complexity of your brute force code. That is also something that we'll be learning and discussing from this particular problem. This particular problem previously has been asked in Flipkart and it might have been asked in other companies as well. So you can just give me a quick +1 in the chat if my voice is clearly audible to everyone and the screen is visible so that I can start as soon as possible, right? So we have Alok Ranjan Srivastav who is giving a +1, Mahesh is giving a +1. All of others can also give me a quick +1 in the chat so that I can start with this particular session as early as possible, right? And also let me know if you have solved this particular problem, that what were the difficulties that you were facing, or you were able to do this by yourself, right? So the problem name is find rectangle with corner as 1, right? So the name of this problem is find rectangle. Hi Shreya. One more thing, I'll be giving you some updates regarding Codera in the end of this stream, so you can just stay back, those who follow me on Codera or other YouTubers videos. So find rectangle with corner as 1. This is the problem. Previously this problem, as I said, it has been asked in Flipkart. It might have been asked in other companies as well. So it's a very good problem, I would say. So let's take this, let's read the problem statement. So the problem statement says that you will be given up, first of all, a binary matrix, right? Now what is a binary matrix? A binary matrix is a matrix in which all the cells are having element either 0 or 1, right? In a binary matrix, all the elements in a cell are either 0 or 1, right? So as you can see here also, so all the cells are having the values either 0 or 1 as elements, right? And you have to find if there exists a rectangle or a square within the matrix whose all corners are 1, right? So let's take this particular example. So I'll just draw, let me just copy it so that I can take this example first of all. So you'll be given a particular matrix, binary matrix, and what you have to do is you have to return true for that particular binary matrix if that particular binary matrix is having if this particular binary matrix is having a rectangle as corners, right? Rectangle, if in that particular rectangle ones are there present in the corners, right? So let me take this example. So if let's say I had 1 0 0 0 then 1 and 0, right? Sorry, I've drawn it the wrong way. So if I had 1 0 0 and then 1 and 0, right? If I had this, then what I had was 0 0 then 1 then 0 1, then I had 0 0 0 1 and 0, and lastly if I had this 1 0 1 0 and 1. So what I have to do is I have to find whether or not there exist four corners which are 1 and they form a rectangle or a square. Basically a rectangle is a square, so we'll consider both as the same. A square can be a rectangle, but a rectangle cannot be a square, so we'll consider to check for a rectangle. Basically we'll check squares in the rectangle definition as well, right? So what I can observe is if I'll clearly check out, so I can see that this one and this one, all these ones, if I combine all of them, right? So if I take them out, so this is forming a rectangle, right? You can observe easily that all this is forming a rectangle, right? You can see that this particular portion is forming a rectangle, right? That is this portion, that is 1 0 1 0 1 0 and then 1 0 1. So you can see that all the four corners are having 1 in the end, and it is a rectangle, right? It is, although it is of dimension 3 cross 3, but it's actually a square can be said to be a rectangle as well, right? So you can easily observe that this is a rectangle that is existing where all the four corners are having 1 as the corner, right? All the four corners are having 1 as the element, so that's why you will return a true for this particular case, right? Please give me a quick +1 in the chat if this test case is clear to everyone, right? Is this particular test case clear to everyone? Just let me know in the chat so that we can proceed further with this particular example. Is this question clear? Is the problem statement clear to everybody? Just let me know in the chat a little quick. Is it clear to everyone? Samar and others, Mahesh, Shreya, all of you can just hit the like button. Please hit the like button so that we can have a head start for this session. All of you can just hit the like button and give me a quick plus one in the chat if this problem statement is clear to everyone. That you'll be given a binary matrix. You'll be given a binary matrix of zeros and ones, and what you have to do is you have to check whether there exists four corners that such that they are forming a rectangle, and all those four corners are having one as the element, right? Like you can see here, as I told you, this and this, all those are ones, and it will form a rectangle, right? So if I magnify it, so it will look something like this. So you can see that it is forming a rectangle, right? Please, all of you, just give me a quick plus one in the chat and like the video if you have understood it clearly, right? So okay, this part is clear. Let's check out for any other test case if there is existing. So let's suppose that this is existing, right? So let's suppose that there is another test case, that is this test case. Suppose that all of them were zero, all of the cells were zero. So if this was 0, 0, all of you can just hit the like button, okay? So it motivates me to bring more detailed editorials. If you have 0, 0, 0, then also 0, 0, 0, right? If I have something like this, then what I will do is I will see, like, can I see that is there anything existing for this particular case, right? For all the zeros, I will return a no, right? Because if I will look at this particular n cross m matrix that's been given to me, binary matrix, I can easily observe that no, there is no rectangle existing such that all the four corners are one, right? Let me change the test case a little bit. So if I change some of the values, let's say if I change this, so if I change some of the values, if I say this, let's say there is one value here as well and here as well. So if let's say this is one of the matrices, right? So I can say that maybe, okay, this can be one of the four corners, this can be one of the four corners. Then I can say, okay, this can be one of the four corners as well. But in that case, this element is not one, right? This element, I can find that this second element in the first row, the second element is not one, right? So that's why I cannot take it, right? Now another thing that I could have maybe considered is that maybe I could have considered this, this, but in this case this 0 is not 1, right? In this case, this element which is 0, it should have been 1, so I cannot consider this case as well, right? So these are the things that I need to consider, that all the four corners should be 1, right? Please give me a quick plus one in the chat if up till now things are clear to everyone, right? And like the video. Please like the video and give me a quick plus one in the chat if you have understood this part, so that we can proceed further, right? That how we can do it. Okay, now let me come back to the test case that was given to us. So I'll just copy paste it here. So this was the test case that was given to us, right? This was the test case that was given to us. So what I can observe is that whenever I am, how will I check for the brute force manner? Can anyone tell me how we can check for the brute force approach? First of all, we'll be having a brute force approach, right? First of all, we'll be having a brute force approach to check, right? So what I will be doing is, let's suppose that what I'll do, let's suppose that at a particular cell, let's suppose I am at a particular cell, right? Let's assume that I am at a particular cell I comma j, right? So let me write it this way. Let's say I am at the ith row and the jth column. So I am at the cell, the position of this, the location of this cell is I comma j, right? So let me write it. So if let's say the matrix that's been given to me is mat, if mat of I and j, right? If mat of I and j is equal to 1, right? So what does it mean? So it means that suppose this particular element, right? This is here I is 0 and j is 0. I know that. But here what is happening? If I run a loop, if I run a square loop, like if I'm iterating through the matrix through a double loop, right? So that means something like this: for I starts from 0, I is lesser than n and I plus plus. Then what I can do is I can start a j for j starts from 0. You can stay back till the end. You will understand the brute force approach as well as how we can optimize it using two ways. So I'll be telling you one brute force approach and two ways, basically three ways, but it will be two only. One will be order of n time complexity and one will be order of one space complexity, right? Space complexity will be changing. So I'll be telling you all the approaches. You can just consider to stay back till the end. So I'll run a loop for this particular matrix I and j, and if a particular index is 1, right? If this particular element is 1, suppose that this is 1, right? So this is 1. Can I say that now what I want is I want someone, like if this is also 1, right? Suppose that this is also 1. So what does it mean? I can find that, okay, this is 1. Then I can see that, okay, I have a 1 here as well, right? Something like this, right? What I can do is, can I say that if I have found, okay, the current matrix of ij is 1, right? I know that, okay, the current index is 1. Can I say that I also need to find another thing, another there, right? I need to go towards the right direction. Can I say that I need to go from this particular cell? Can I say that I need to go towards the right direction and find a cell, as well as go towards the down direction and find a cell, right? So that I can find, basically I need to find 3 more cells. If the current cell is 1, all of you can just hit the like button, right? So that the video reaches as many people as possible, and just give me a quick +1 in the chat if up till now everything is clear to everyone, right? Because I'm trying to explain in a little bit of detail. I can say that the current cell is this white cell that I have marked. The current cell is value is 1, right? I'll just check for the audio. So that I can find, basically I need to find 3 more cells. Okay, right. So it's perfectly working perfectly fine. So if this is the current cell, what I'm saying is, if I'm at the current cell, if I go down and I go towards the right, then I need to find the cells which are 1, right? So can I say that if the index of this particular current cell, if the index of this cell, right, if the index of this cell is I comma j, right, if the index of this cell is nothing but I comma j, right, can I say that if I'm going towards the right, then my ith row is remaining the same? So I need to find a cell such that I need to find I comma right, I need to find a cell at the in the same row, that is the ith row, and at a particular index, right, which is 1. And then what I need to do is, I also need to find a cell in the jth column, right, in this particular column, same column. So I need to move down. So can I say that I need to find for row, I need to change my row, right? If I move right, then my row will remain the same, my I would remain the same, right? If I am moving this way, my I is remaining the same, and this column is changing, right? So I need to find a right column which is having a cell 1. Maybe I can say, okay, this is one of them, right? So I can say this. So for the index for this would be I comma right. Another way I can move down. If I move down, so I find this particular cell, so its index is nothing but the row is changing, the column is the same. So the index of this will be nothing but, if I'll mark it, so it will be nothing but matrix of mat of something like a down comma j. Please give me a quick +1 in the chat if this much part is clear to everyone, right? That, okay, this is how the indexing is being done. That if the element at the ith row and the jth column is 1, then I need to find a cell towards the right. I need to find a cell towards the right which is 1 in the same row, that is ith row is remaining the same, and I need to find a cell towards the right direction from my I, and also I need to move towards the down direction. And I need to, all of you can just give me a quick +1 in the chat if this much part is clear, or you can comment down right clear in the chat, right? Now I also need to move down because I'm checking for a rectangle, right? So I also need to move down. I need to check that, okay, I am changing my row, so the row will become down, some row, like assume that it is down, and the column would remain the same, the column will remain j, right? So this, if these two are ones, right, if I say that, okay, this is the thing, so what observation I make, if for the ith and jth, and I find that if I keep the row same and I find a right column as well in the same row, ith row, if it is 1, and I find that if there is some mat such that mat of down comma j, right, this particular column, it is also 1, right, it is also 1. So can I say that I need to find one more cell? All of you can just like the video and give me a quick +1 in the chat. I know that this is a little bit tricky, it might seem a little bit tricky, but believe me, it's not, right? So what I'm saying is, if this was the ith row and the jth column, so if this was the ith row and the jth column, then I need to move towards the right direction. I need to find in the same ith row right column which is having 1, right, where the matrix cell is 1, right? Repeat -1, repeat right, down once more. Okay, I'm saying that I need to find a rectangle, right? If I have the cells, I need to find a rectangle. Can I say that if I need to find a rectangle, all the corners, so if I'm saying that, okay, if this I comma jth column is 1, right, if I'm saying that, okay, this I comma jth column is 1, then in that case I need to move towards the right and I need to be in the ith row only, and I need to find a right column, I comma right, a column that is matrix of I comma right, which is 1. I need to find this, and I need to move down as well. So again, I can find this kind of a cell which is 1. So my jth column would remain the same. I'll remain in the jth column, but since I'm moving down, so the row would change. So I need to find down comma j, which is 1, right? if I find, if for the ith, if the ith jth are 1, then I need to find the towards the right I need a loop, and towards the down also I need a loop, right? So if these two are ones as well, so if this is and this is also 1, then what will be the index of this particular cell? This cell will be nothing but, the index of this cell will be nothing but down comma right. Okay, down comma right. Is this much part clear to everyone? That if this cell is having the column as right, and this cell is having column name as down, so this cell will have the column as right and the cell as down, right? So I need to say that, okay, if this is the case, then I need to check that whether there exists down and j also, down and right also, which is equal to 1. This is what I need to check, that if ith and jth are same, then I'll run a loop inside them, right? I need to run towards the right side as well as the left side. So if I find that, okay, the ith row and the jth column is the same, if ith row and the jth column is 1, in that case what I need to do is I need a loop towards the right direction and a loop towards the down direction. So basically I need another nested loop inside, and what I want is, I want that, okay, ith and jth are ith row and jth column is 1, so that means I need to move towards the right. If ith and right is 1 and down and j is 1, then I also want that down and right is 1 as well. If these four conditions are satisfied, in that case I'll say that, okay, I'll return a true, because in that case I'll say that, okay, my answer is existing. How can I say this? So just give me a second, I'll make some space and I'll let you know how I can confidently say this part. All of you can just give me a quick +1 in the chat if up till now things are clear. Now I'll show you with the help of this diagram. Suppose this was my ij, right? Suppose this was my ij. So suppose this, if I do the indexing part, so this will be index 0, 1, 2, 3, 4. This will be index 0, then 1, 2, 3, right? So that means matrix of this, if matrix of what? 1 and 2, if mat of 1 and 2 is 1, right? So this particular cell is 1, right? So can I say that if this is 1, so I need to run another loop. So I need to run two loops, two nested loops inside. So if this particular I comma jth cell, this is nothing but mat of I comma j. If this is 1, then what I need to do is I need to run another loop. One I need to run towards the down. So down starts from nothing but I plus 1, and like in the row side I need to, if this is my current row, so I need to move towards the down rows to check if there is a row existing or not. So I need to move down is equal to I plus 1 and down is lesser than n and down plus plus, right? Another thing that I need to do is I need to find the column as well. So I'll do this, that is all of you can just consider to like the video, right? So I need to find towards the right as well. So I need to move right is equal to j plus 1, because if this is the jth column, then I need to find from this side, right? Okay, because if this is 1, if at this particular index is 1, so I will find 1 here, right? So I need to move from j plus 1 and right is lesser than m, right? And I need to do right plus plus like this. And what I'll do is as I told you, just let me get back to it. Okay, what I'll do is, this much part must be clear, right? That if this is 1, so what I'm saying is, let me talk in terms of numbers, right? Now I have told you that how the loop will be running. If I find I comma j, if I find a particular index I comma j, that is 1, if I find that, so what I'll do is I'll run a loop in the right direction. I'll run a nested loop, that is I'll iterate through the leftover matrix. So if this much part is there, right? If this much part is 1 1, so what I'll do is I need to check for this matrix, right? Because this is the matrix that I need to check. I need to check for the right side. Okay, if this cell is 1, so that is what I'm doing. If this cell is 1, if ij is 1, if this cell is 1, then I need to check in the right. So I can see, okay, in the right this particular cell is 1. So what is the index of this cell? The index of this cell is nothing but I can say that, okay, the matrix of 1 comma 2 is 1, right? Then I can say that, okay, if that is the case, so matrix of 1 comma 4 is 1 as well, in the same direction, in the same right direction I'm moving, and this is 1, right? All of you can just give me a quick +1. Now I need to move down. I can say that, okay, this is also 1, right? This is when I'll be running a nested loop inside. Once I find this I comma j is 1, so I'll be running two loops inside this, right? So this is what I'll be doing. So now if I have matrix of what? 3 and 1, 3 comma 2, right? So I'm moving in the down direction, so my common column remains 2, but my row changes to 3, index 3. So mat of this is also 1, right? So if this is 1, right, I'm running nested loops. If this is 1, if ij is 1, right, and I of right is 1, this is nothing but I comma j, index I comma j. This is nothing but I and right, and this is nothing but down comma j, right? So I also need to find a matrix. I need to find that whether matrix of at this particular index, matrix of down comma right, whether it is 1 or not. Okay, so that means I need to find which index. My right value, down value is 3 and the right value is nothing but 4, right? So I need to find whether or not matrix of 3 or 3 at the index row 3 and column 4, whether it is 1 or not. So I can see that okay, this is also 1, this is also 1. In that case, I'll simply return a true. Otherwise, once I have iterated to the linked list, if not the linked list, sorry, through the matrix, in that case I'll return a false, right? Is this much part clear to everyone? Please give me a clear in the chat if you have understood this, that you are at this particular I and jth index, so you'll keep the row same, you will keep the row as I, and you will find a right cell towards it. You will change the column, so you'll find a right column such that in the same row you have a column which is having 1, right? After that, you need to move down as well, and you will remain in the same column here if you are checking for this. So you'll remain in the same column and you will move down in another row, and you will find, if you find this and this cell, then you want this cell to be 1 as well, and in that case you will return a 1, right? Please give me a quick +1 in the chat if you have understood this part. I'll show you the code as well for this particular thing, how I have done this. So basically what I'm doing is, I have this particular cell, right? I have this particular cell. I have first of all the rows and columns. So I'm running I is lesser than row and j is lesser than columns. If the I comma j, if matrix of I comma j, right? If I comma j is equal to 1. So if I comma j is 1, then I need to move towards the right direction as well as the down direction, right? So that's why I'm running nested loops, right? I am running loops inside it because I need to find, right? I need to find. So that's why I'm running in the right direction as well as the down direction. Now it will be nested. Why? Because I need to check for all the combinations, right? So that's why it will be nested. So the time complexity for this would be order of n, this would be order of m, this would be order of n, and this would be order of m, right? So that's what I'll be doing. So basically what I'll be doing is, if I find that okay, if I find that this particular right cell is 1, right? If I find that okay, in the ith row I'm having a right cell as 1, if in the ith row I'm having a right cell as 1, then I need to check for the down direction as well. I need to if in the ith row I found that okay, there is 1 column existing, so I need to check whether in the same in the same column, whether there is a row downwards that is having 1 as well or not. So I'll check whether matrix of this is existing or not. If that is the case, so in the end what I'll check is like this is what I'm checking, right? If down and j is 1, so I also need to check if down and right is also 1 or not. If all these 4 conditions are met, so basically if I comma j is 1 and correspondingly downwards in the same row and in the same direction, in the same row and in the same column, I have a matrix as 1, then I need to check okay, down and right are 1 or not. If they are 1, then in that case I'll return a true. Please give me a quick +1 in the chat if you have understood this part, right? So basically what I was doing was, I was running 3 loops. So what I did was, I ran a loop for the row. So I starts from 0, I is lesser than n, and I did I plus plus, so it will take order of n time. Then I was running a loop for j starts from 0, j is lesser than m, and j plus plus, so it would take a time complexity of order of m. After this, if my matrix of ij was 1, if ij was 1, then what I was doing, I was running 2 loops inside. So right was starting from I plus 1, and right was starting from I plus 1, it was basically starting from j plus 1, right? So j plus 1 and right was running until m, so j plus plus, so it would take order of m time, and another loop that was running down, it would take order of n time. So overall the time complexity of the brute force approach that I am telling you, it will take order of n into m into n into m, so that is order of, you can say order of n square into m square, right? Is this much part clear to everybody? I hope that it is clear to everyone, right? What I have done is this much part clear to everyone. You can just write clear in the chat so that I can tell you that how we can try to optimize this particular approach. If I'll do it the brute force way, so the time complexity overall would be order of n square m square, right? Order of n square into m square. Basically what I've done, if you have this particular grid, right? If you have this particular grid, so what I said was, if this particular row is having a 1, then you need to find in the right direction. If this is also 1, then you need to find okay, if is there something downwards, is there something downwards. So basically one time you need to change the column, one time you need to change the row, and you need to find okay, this is 1, okay, this is 1, so that means this should also be 1, right? So if this is nothing but I comma right, and this is nothing but I comma j, and this index is nothing but down comma j, so this right comma this down comma right should be 1 as well, right? So that's what I'm saying. Please give me a quick plus one in the chat if you have understood this part, right? So that's what I was saying. Now another way to do it could be using the concept, that is using the concept of either using the concept of hashing, or you can also consider to use the concept of counts. So first of all, I'll show you how we can do it using the concept of hashing. So if I have this particular cell, right, what I can say is just give me a minute, I'll draw some values for you, right? So if I say that, okay, this is index 0, this is index 1, 2, 3, 4, this is 0, 1, 2, 3, right? This is the index. Now notice one thing, that what was the test case that was given to us. All of you can just give me a quick plus one in the chat and like the video as well, right? Please give me a clear, please write clear in the chat if you have understood up till now, so that I can move forward, right? Now the thing is that I'll be at this particular index. If I see, so these are the indexes, right? Notice something special about these indexes. Can you notice something special about these indexes? If you will notice, can you notice something special? That what are the indexes? What are their values? So if you will see, so this is 1, this is 1, this is 1, this is 1. What is this? This is 2, this is 4, right? The index, the column part. This is 2, this is 4, this is 2, this is 4. Can I say that in row is equal to 1 in this particular row, right? In this particular row, can I say that in this particular row, at row is equal to 1, I have column at column 2 and column value is equal to 4. I have this thing. In row is equal to 1, I have column is equal to 2 and column is equal to 4, right? This is what I can say. Another thing that I can observe is the same pattern that I can observe, right? The same pattern. Now notice for this row number 3, right? Row number means row indexing is 3 because the indexing is starting from 0. And in row number 3, let's try and observe. Let me change the color of the pen. Let's observe in row number 3 as well. If I will observe in row number 3, can I say that column is equal to 2 and column is equal to 4 is also 1? Can I say this, that in row number 1, in this row, the column this and this is 1. In the row number 1, this column and this column is 1. Then in the row number 3, this column and this column is 1. So that is how you are making a rectangle. Does this make sense? How have I observed this? Please give me a quick plus one in the chat or clear in the chat if you are able to observe this part, right? A quick plus one in the chat would help. A quick plus one in the chat. All of you, please give me a clear in the chat or a plus one in the chat if you have understood this part. That is what I'm saying is, if I am at the particular current row, right? If I am at the current row, I see that, okay, it is having this row and this row is 1, right? I can say, okay, in the row 1, I had column as 2 and column as 4 as 1. And in row number 3 as well, I have column 2 and column 4 as 1. So I can say that, okay, that means that a rectangle is existing with corners as 1, right? This particular rectangle would exist, right? Is it clear to everybody? Is it clear to everyone? Please give me a quick plus one in the chat. Like Alok, Ranjan Srivastav, Naren, Samar, Mahesh, and Shreya. All of you just give Mahesh, all of you others, please give me a quick plus one in the chat if you have understood this part, right? Okay, this is what we are doing. So that is what we need to observe. That now I'll draw it again for you. I'll draw it once again for you to see how we are observing it, right? All of you can just give me a quick plus one in the chat if you have understood this particular observation up till now, right? Let me copy it here again. So all of you can just give me a quick plus one in the chat if you have understood it. Now what I'm saying is, I'll iterate for each row, right? This is row number 0, this is 1, this is 2, this is 3, this is 0, this is 1, this is 2. Yashwadhan is saying a plus 1. What about others? Others must have also understood it, right? So all of you can just give me a quick plus 1 in the chat so that it eases our process of doing it, right? Okay. Now the thing is, what I'll do is, I'll try to make a map, maybe, right? Maybe I can try to make a map. So if I'll see in row number 1, what I can observe is, I can observe that in row number 1, the column is equal to 1 and column is equal to 3. Basically this particular column and this particular column are 1, right? Then what I'll do is, I'll try to make some more observations. So I can say safely that, okay, I can say like this one and this one, right? This is 1. So this is what I have observed. Now what I'll be doing is, now I have row is equal to not 0. This was row number 0, right? So this will be row number 1. This will be row number 1. This particular row that I am talking about. So in this row, I can easily observe that at the column number 2 and column number 4, I am having 1, right? So I can say that, okay, in column number 1 and column number 2 In column number 2 and column number 4, I am having 1, right? After this, what I will do is basically I might be storing these data in a particular data structure, right? So I will be doing this, but I'll let you know what we are actually able to observe. So if I check for the next row, if I'm at the next row, what I can do is I can easily say that in the next row this is only 1. So I can say that okay, in this row the column is equal to 1. Column is equal to 1 is at the index number 3. So column is equal to 3 is 1, right? That is something that I can say. But now the twist is there. Now the twist is there. You can easily observe that at row is equal to 3, I have column is equal to 1, column is equal to 0. I have this thing, sorry. Okay. Yeah, column is equal to 0. Like this particular column is 1. This particular column is 1, this particular column. So this is the 0th column, this is the first column, this is second, third and fourth, right? So I can say that okay, these are the columns that are having values as 1. So I'll say okay, column is equal to 0 is one of them. I'll say okay, column is equal to 0 is 1. Then column is equal to 2 and column is equal to 4. Now observe one thing. If you store this particular data in a map, right? Alok, Ranjan, Srivastava and Shreya, Mahesh, Yashwant and Naren, everyone else. Now you can observe. What can you observe? You can observe that if you had to store this in a map, so you can easily observe that okay, now you can observe that at column number 2 in any row, it can be in any row, but I can easily observe, I don't need to return which row I am finding it, but I need to see that okay, at column 2 and column 4 is having 1 in some row, in this last row, column 2 and column 4 is 1. So that means this particular thing, I'll just let you know, just give me a second, just highlight it. So this and this is 1, right? But I'll check in, if I keep a track of this in an unordered map or in a hash map, what I can easily observe is, that this column is equal to 2 and this column is equal to 4. Like column 2 and column 4 and column 2 in another row are 1 as well, right? So that means this particular pair 2 comma 4, this particular pair of columns 2 comma 4 is already existing, right? Currently this is the pair, right? 2 comma 4 is the pair that I have here, but I also have a 2 comma 4 pair earlier existing. So does that not indicate that okay, there is a rectangle existing? Like you can see here, you can observe that okay, at this particular column number 2, this particular column 2, column 4, this particular column number 4, its value is 1. So in that case, I will return a true if it is already existing in my map. Please give me a quick plus 1 in the chat if you have understood this part, right? If you have understood this part, please give me a quick plus 1 in the chat, how you have observed it, how we have tried to observe it, right? I'll let you know about the time complexity and the thought process a little bit, but this is one observation that I've made. Just give me a quick plus 1 in the chat, Shreya, Mahesh, Alok, Yashwant and everyone else, Samar. Everyone just give me a quick plus 1 in the chat and hit the like button if you have understood this observation, that what the observation I've done. Basically, if I check for each row, if I mark that okay, this column, like pairwise, every time pairwise I do it, so I can easily find that okay, this 2 comma 4 column is existing earlier and it is existing now as well, right? All of you just give me a quick plus 1 in the chat or write clear in chat, right? Okay, you have understood this part, right? That for each row, if you each row you are there, in each row you are there, you're marking the pairs, right? You have here the pair 0, 3, all these pairs. So you know that okay, in this particular last row you have a pair, you have total 0, 4, one pair, this pair, one of the pairs is this. I'll tell you what are the pairs that are existing. One pair is this pair, another pair is this pair, another pair is this pair, right? This and this pair. So basically you can say that okay, the pair 2, 4 is existing. Can BFS help? No, BFS will not help in with this particular situation. Why will you don't need to do a BFS traversal for this, only the matrix traversal will help, right? So I can easily say, because you need to move, right? So basically I can say that I can do it in something like, I can reduce how many loops I have reduced. That is one thing, right? So I hope that the hashing part is clear to everyone, right? How I am going to hash. Basically 2, 4 is existing here as well. So this particular cell 2, 4 in one of the rows, and I had already this pair 2, 4 made. So that means that the rectangle is existing, right? That would simply indicate that the rectangle is existing. Now the challenge that lies ahead of me, BFS is so brutal. Okay, or why is it brutal, man? It will not be useful for this particular question, right? Okay, now the thing is that okay, this is something that I've done, right? This is something that I've done. Now the thing is, how hashing part is also clear, that okay, I'll be having a pair 2, 4 of the column, this particular column, this particular column, and this particular column, and it will pair up with this particular column and this particular column, right? So that's perfectly clear, right? That's perfectly clear. But the thing is how to run the loop. How to run the loop. So you can do it in both the ways. Now I'll tell you one more thing, if you want, or first of all I'll clear this part only. So just give me a second. I'll just copy paste this again. So I'm trying to generate the intuition for this. One, like if you had seen this question for the first time, then what would be your approach? What would be my approach for solving this? Now the thing is, I can say that I'm changing rows every time or something like this, right? Or I'm changing the columns. I can easily say that what I'll be doing is, for I starts from 0, can I say that okay, can I say that 2 comma 4 was the pair of the columns, right? So I said that okay, this column, right, this column is making a pair. So this column 2 comma 4 column is making a pair with 2 comma 4 column as well. Can I say create combination of row for 1? Yes. So for that you will be running a loop, right? So I can say that okay, row number 1 and row number 4 was there, row number 3 was there, right? Can I say this, that okay, this row is equal to 1 was there and this row is equal to 3 was also there, right? I can say this, right? So that's why what I need to do is, I told you earlier that by telling all the, I'll be checking for all of them, right? For every column I'll be checking. So what I can safely say is how the way of doing it can be made much more easier. How we can do it easily? So basically what we can do is we can run two nested loops for the rows, right? Every time I'm checking, right, that I observe what I was able to observe that at row is equal to 1, column is equal to 2, and column is equal to 4. And I also observed that okay, at row is equal to 3, column was equal to 2 and column was equal to 4. Basically this pair 2 comma 4 was existing here as well as here, right? So can I say that I was checking for, let's say for row 0, row is equal to 0, I was checking for row 0 with row 1 with row 2, like this, then I was checking every time, right? So this is something that I was doing. So let's observe how we'll do this. So what I'll be doing is, I'll just mark this again. Just give me a second. Okay, is this much part clear to everyone? Is this much part clear to everyone? Please write clear in the chat and give me a quick +1 in the chat, because I'm trying to explain every observation, every intuition for this particular problem, right? So what I'll be doing is, I can safely say that okay, I'll start one of the rows could be this, then another row could be this, right? I'll check for this row and this row, then this row and with this row, right? This is what I'll do. Then what I'll do, I'll check for this row with this row, right? Like this. Okay, I'll generate a combination, right? I'll first of all check row is equal to 0. I'll mark the rows. This is row 0, 1, 2, 3, right? So I'll check row 0 with row 1, the combinations. Then I'll check row 0 with row is equal to 2, like this. Then row is equal to 0 with row is equal to 3. Then I'll check row is equal to 1 with row is equal to 2, like this. Then I'll check row is equal to 1 with row is equal to 3, like this. So I'll be checking for each of the pairs. Is this much part clear to everybody? I hope that makes sense, right? Please write clear in the chat so that I can understand that whether you have a concept of this or not, right? You are checking for all the combinations of the rows as well, right? So that is what you are doing, right? For each row you are checking every time. So that is what you are doing. So what I'll be doing is, I can easily say that I can run a loop for my I starts from 0. I is lesser than n, where n is the number of rows, and I plus plus. And what I can do is, maybe I can start a j. J is equal to nothing but I plus 1, and j is lesser than n, because I need to check for each of the rows pairs as well, right? So what I can say is that I need to run for the columns, right? So I can say that okay, I can run the column starts from 0, column is lesser than m, and I can do a column plus plus like this, right? And what I need to do is, I can simply say that if this is the situation, right? If this is the situation, in this particular situation, if for the ith row and this particular column, right? If in this particular row, right? If in this particular row, if this column and this column is 1, right? If in a particular row, this column and this column is 1, can you say that okay, in this row and this row it is 1? Maybe I can make a map, I can store them in a map or something, and I can do it, right? Is this much part clear to everyone? That I can, first of all, for this particular row I can store it, then I will be able to check for all the combinations, and then when I will be at row is equal to 1 and row is equal to 3, when I will be at this particular combination, then I'll get okay that this pair is existing and this pair is existing. So that will simply indicate that okay, that simply indicates that this is how it will be done. Is it clear to everybody? Is it clear to everybody? Please let me know in the chat. I hope that it's clear to everyone, right? This is what I will be doing. Is it clear to everyone? Please write clear in the chat. A quick plus one in the chat would help. Basically what I'm doing, everything is clear to you. You can also do it column wise. How you can do it column wise as well, I'll let you know that as well. Now I'll let you know that as well. You can, instead of looking in the row wise fashion, you can also look in the column wise fashion. How? 0 1 2 3 4 0 1 2 3. Right? So this is something. Let's observe one thing. Let's observe. This is what? This is column number 2. Observe, this is column 2, this is column 4, right? And this is having ones and ones. Now observe one thing here, that what I need to observe is, I have this thing, that is this particular column. In column is equal to 2. Can I say in column is equal to 2? In this particular column, the row number 1 and row number 3 are having values 1. In the column number 2, if I'm looking in terms of columns, so in column number 2, row number 1 and row number 3 are 1. So I can say that, okay, row number 1 and row number 3 are having the values as 1. I can similarly say that, okay, in column is equal to 4, in this particular column, last column, in column is equal to 4, in this row number 1 and row number 3, this particular row, and row number 3, in row number 1 and row number 3, I am having ones as well. So this is also one of the approaches that I can do it, right? I can either check in terms of columns, I can either check, either I can run the two rule, either I can do it in the time complexity of order of n into m, right? Like that is something like, if I'll tell in the simpler manner, so it will be nothing but order of n square into m, something like this, or I can do it in order of n into m square, right? Does this make sense? Either I can check it column wise, either I can make all the combinations of the columns, or I can make all the combinations of the rows. So that depends on me, what I want to do. In that way I'll be running the loops, right? Is this much part clear to everyone? And whenever a particular is existing, if I am storing this in the map, that I am storing the all the row pairs 1 comma 3 in this map, and 1 comma 3 is again I'm getting, and if it is already there in the map, so that will mean that, okay, if I am in another column and 1 comma 3 is appearing again, so that means that this particular cell is having the boundaries as 1, right? Does this make sense? Please write clear in the chat if you have understood this part very clearly, right? You can also avoid using the columns. How you can avoid using the columns? You can keep a count. How you can keep a count? You can also keep a count. How you can keep a count? If you will look at this particular column, so you'll say that, okay, this in this particular row, this column and this column is 1, right? You can say this, right? In this particular row, this column and this column is 1. You will say this, right? All of you can just give me a quick plus 1 in the chat if you have understood this part, and hit the like button, right? Now if you are at this particular row, so you can say that, okay, this column and this column is set, right? This column and this column is having a value 1. So what you can do is, if you keep a counter that, okay, this value and this value is 1, and then you check again, right? Then you keep on counting, for this particular combination of rows, and if your counter is greater equal to 2, right? If your counter is greater equal to 2, in that case also you can say, very safely say that, okay, I'm existing, right? If this particular for this particular current row, if this column and this column is 1, and this column and this column is 1, so I can say that, okay, for this particular column 2 and column 4, it is I'm having in two different rows, the count of rows which are having this particular, the count of rows is equal to 2 for count of rows is greater equal to 2 for this particular concept, right? That is, the count of rows for this particular row, I have column is equal to 2 and column is equal to 4. It is set in 2 rows, right? So I can say that if the count is greater equal to 2, in that case I will safely return a true, right? Now let me show you what I have said. Also, let me show you that my code is working first of all, so that you can understand it. Now we will come to the conclusion part, right? I have told you already that the time complexity would be either of order of n square into m, or n into m square, whatever way you are doing it. Now what I need to tell you is, if you are doing it in terms of this, right? If you are running for n square into m approach, I'll show you the both of the codes. First of all, you can take the screenshot of this, because this code will get accepted, right? If you want, you can take a screenshot of this particular code. What I'll be doing is, I'll be running I from this and j from this, right? So I'm checking for all the rows and all the column, all the row and to the column pairs, right? All the rows pairs, right? So for this row, basically this is the approach of n square into m, right? So I'm checking that if the ith column is set, if the ith column in the ith row the column is set, and in the jth row if the column is set, so I'm incrementing the count by 1. After this is done, I'll check if the count is greater or equal to 2, then in that case I'll return a true, right? Another thing that I could do is, if I'll just control Z it, so I could do it in terms of rows as well. Like this, I could run in terms of columns. So this would be order of m square into m into n approach, that is m square into n approach. Basically in this approach what I can do is, I can start I from 0, I is lesser than m, j starts from I plus 1, j is lesser than m, like this, right? So I have told you, right, you can do it, you can look at in terms of columns changing or in terms of row changing as well, right? So here I'm considering it in terms of column changing, right? I'm generating all the pairs of columns. So in this way what I'm doing is, if the ith column for the row, current row, if the ith column is set and the jth column is set as well, right? So in that case I need to increment my count. And if for that, so let's say that pair was what, right? If for the row is equal to 1, I was having the pair, right? If for row is equal to 1, if for row is equal to 1, right? Suppose that for row is equal to 1, for row is equal to 1, I was having what? I was having column is equal to nothing but this thing, column as 2 and column as 4, right? Column as 2 comma 4 as the pair, right? I had 2 comma 4 as the pair. Then for row is equal to what? Row is equal to nothing but 3. For row is equal to 3, I had this 2 comma 4 occurring again, right? 2 comma 4 occurring again. Now if the counter is 1 here, like here the counter would be 1, then the counter would increase to 2, right? If the counter is 2, if the counter is 2 or greater, so that means a rectangle is formed. In that case I'll return a true. Please write yes +1 in the chat and like the video if you have clearly understood this part, right? So I've discussed with you basically 4 of the approaches. I'll just summarize them for you. If you feel uncomfortable, that could be because I've explained a lot of approaches. So basically first approach was to do it in order of n square into m square approach. Then another way to do it was using the order of n square into m approach. Another way to do it was using the order of m square n into m square approach, like this, right? Now for these two approaches, either you could use the concept of map. In that case the space complexity would increase, right? In that case you will have some space complexity, or you can use the concept of count. In this approach also you can use the concept of map, or you can use the concept of count. Please write clear in the chat and a +1 in the chat if you have understood this part. If you have stayed with me till the end, then what you can do is, you can consider to subscribe this channel that we have, that is Codera. This is a channel that is powered by Geeks for Geeks. So on this particular channel we host a lot of videos based on data structures, algorithms, competitive programming and things like that. So you can consider to like this channel, share this channel with your friends, and just give me a quick +1 in the chat if you have understood this till now, so that I can get a clear picture. And thanks a lot for watching everyone, and I'll see you soon in the next